Hello everyone, this video is going to review Objective 2 for our Hooke's Law and Elastic Potential Energy Lab. So for Objective 2, we are looking to develop an equation for elastic potential energy by looking at the area under the curve of our graph. So here we have our graph from part 1, where it's the force of the spring versus displacement. So we're going to look at this area under here. So we see that is a triangle. So we're going to take the area of a triangle, which that area is going to become our elastic potential energy. So in our math kind of language, 1/2 base times height is the area of our triangle, but we need to convert that to physics. So the base of our graph is measuring displacement, so delta x, and the height, or the vertical part, is measuring the force from the spring. So right then and there, that would be an equation that we could plug in our displacement and our force to get the energy. But we need to express it in terms of k and delta x. So we're going to need to factor out the force. So using our Hooke's Law equation that we developed in the first part, we're going to substitute that in for the force. So we have 1/2 delta x, and then for this force, we're going to plug in k delta x. And then we can combine like terms, and then that becomes our equation for elastic potential energy, where delta x is squared. And as far as units go, we would get k, which we have measured in newtons per meter, times our displacement squared, so meters squared. So one of the meters is gone, so we're left with a newton times a meter, which is equal to a joule. All energy and work can be expressed in joules.